Our next volume video is volume of cones. What we're going to discuss here we call right cones. Right, so they're standing perfectly straight up, and there's a circle at the bottom. So to calculate the volume of a cone, it looks very similar to the volume of a cylinder, and it is. The only difference is that you take a third of that volume. Alright, so what we're going to look to find is the radius and the height. Just like we did for cylinders, though, sometimes we're going to be given what we call the slant height. The slant height is not the height, but it's actually the distance from the apex of the cone to this point over here, kind of right down the edge of the cone. That's called a slant height, and we'll call that lowercase l. So if we're ever given that, hopefully you can see that it makes a nice right triangle cross section right there. So we're going to have to use our Pythagorean theorem sometimes. Number one. First example is, let's see, 1/3 pi r squared times h. Problem's telling us that the height is 22, the radius is 7. So everything that we need is given here. So all we need to do is go to our calculators. We go 7 squared times 22 pi, and then divide that whole thing by 3. We get 1128.879. And volume, again, is the amount of stuff that kind of fits inside here. You know, when you think volume, think liquid. How much stuff can fit inside. And volume is a cubic measurement, so we say cubic inches. Number two, the slant height of this cone is 13, so that's going to be this distance right here. That's 13 centimeters. And the diameter of this thing is 10 centimeters. Notice that we do not know the height. The height of this thing would go right down the center and end up right in the middle. We have no idea what that is right now. So we have to find that. All right, in order to find that, you're simply going to want to turn this 3D solid into a nice right triangle. So it's 13, it's h, and just like we did with the previous cones and the pyramids and stuff, this is not 10, but it's 5 because you're just looking at half of the diameter, right? You want the radius. So this is about as simple as right triangles can get. We're going to go h squared plus 5 squared equals 13 squared. And let's see, h squared plus 25 equals 169. Subtract, you get 144, so h is 12. Alright, we're just going to take the square root of 144 right there and get 12. So our height is 12 centimeters. So here we go. Volume is 1/3 pi r squared times h. 1/3 times pi times the radius. Be careful not to use 10 here, common mistake. And the height is 12. So let's see, it's going to be, I think 100 pi. Let's see, 25 times 12 times pi divided by 3. Yeah, 314.159. And that's centimeters cubed, cubic centimeters. Number 3. Alright, each of these plastic cones is 4 inches in height. So 4 inches in height and 1 inch in diameter. So radius is half of that. Radius is 0.5 inches. A chef fills each of them with 3 inches of root beer with plans to turn them into slushies. Alright, that sounds good. How much root beer does she need? So the height is actually, in this case, not 4, but the height for our problem is 3. Right? She's only filling them with 3 inches of root beer, so that's going to be our new height. Right there. So those are our two pieces of given information. We also, of course, have 1, 2, 3, 4, 5. We have 10 cones altogether. So let's find the volume of one of them. 1/3 pi r squared times h. We don't want to go all the way to the top. We only want to go up to 3 inches. So we'll change our height to 3. Let's calculate that. Well, the cool part about some of this is, like, if you ever have a 1/3 and a 3, 1/3 times 3 is 1. So this is just going to be 0.5 squared times pi. So that's going to be our volume of one of these things, which is 0.785. And that's the volume of one. Multiply that by 10. So you just kind of move that 2 places to the right. So this is the total volume. The total volume is 7, or 1 place to the right rather, 7.854. And that's cubic inches. So that's how much root beer she would need to fill these cones up if she wanted to turn them into slushies with a height of 3 inches.